This is section 2.2, linear relations and functions, and section 2.4, writing linear equations. Our objective is I can write the equation of a line given the slope and a point. Relations that have straight line graphs are called linear relations. Relations that are not linear are called nonlinear relations. An equation like x plus y equals 5 is called a linear equation. A linear function is a function with ordered pairs that satisfy a linear equation. Any linear function can be written in the form, should say, f of x equals mx plus b, and in that case, m and b are real numbers. Example 1. Identify linear functions. State whether each function is a linear function. Write yes or no. On A, we have f of x equals 8 minus 3 over 4x. And on the first page of your notes, it says the things that linear equations have are addition, subtraction, multiplication of variables by constants, and line-shaped graphs. And then it also says some things that linear equations cannot have. Variables being multiplied together, variables in the denominator, or variables with an exponent greater than 1. So basically when we're looking at these, we want to make sure it doesn't have any of the things that it's not supposed to have. On example A, we are looking to see, is this going to be linear? So first we want to say, is there any variables being multiplied together? And in this case, there isn't. Then we ask ourselves, is there a variable in the denominator? And there isn't one of those either. And then we know that there's not an exponent greater than 1, so we know that A is going to be linear. For B, it says f of x equals 2 over x, and right away that shows me that it's not going to be linear because we have this x that's in the denominator, and we're not allowed to have that. So we're going to go ahead and say no. And then for example C, we have 3xy minus 4, and again we have something that, a rule where it's being broken. We have an x times a y, and that's not allowed. We're not allowed to have variables being multiplied, so no. The slope of a line is the ratio of change in the y-coordinate corresponding to the change with the x-coordinate. The slope of a line is the same as its rate of change. In example 3, they want us to find the slope of the line that passes through negative 4, 3, and 2, 5. The first thing I'm going to do here is label the points. So I'm going to call it x1, y1, and x2, y2. And I always do this, even though I've done these problems a million times, because it's really helpful to be able to have them labeled so that you don't have to wonder which one's y2, which one's y1. So, when we're finding the slope, we know that our equation is m equals y2 minus y1 over x2 minus x1. So, when we go to do this problem, all we're doing is plugging the values that we labeled in. So we have m equals y2, which we said was 5, minus y1, which we said was 3, over our x2 value, which was 2, minus our x1 value, which was negative 4. And since we have the two negatives, we can go ahead and change that into a positive. And then we can go ahead and solve. So 5 minus 3 gives us 2. 2 plus 4 gives us 6. So we end up with 2/6. And we can reduce that and go ahead and say 1/3 is our slope, our final answer. If you were given the slope and y-intercept of a line, you can find an equation of the line by substituting the values of m and b into slope-intercept form. In example 1, we're supposed to write an equation in slope-intercept form for the line seen. So there's two things that we need. Well, first, we know that our equation is y equals mx plus b for slope-intercept form. So we need to find m and we need to find b. So by looking at the graph, we already can tell what b is because we can see that it crosses the y-axis at 0, negative 2. So we know that the y-intercept, or b, is negative 2. but we do need to find the slope. So we can either, some students like to just look and they count, rise over run. So we know we're going down 1 and over 4, so we know that the slope is negative 1/4. But some students have a harder time seeing how to do that. So they like to use a formula. So I'm going to go ahead and show you how to do that. We're going to do it the exact same as we did the last one, y2 minus y1 over x2 minus x1. And we have a couple different points that they gave us. They gave us -4, -1, and they also gave us 0, -2. And again, I'm going to label those x1, y1, x2, y2. So if we go ahead and plug those values in, we're going to have -2 minus -1 over 0 minus -4. In both cases, I have double negatives, so I'm going to make it a positive. So I have -2 plus 1, which is -1, and 0 plus 4, which is 4. So we know that our slope is -1/4. And then all we have to do for our final answer is plug in the values that we got. So we would have had -1/4. Don't forget your x. And then we can either write plus -2, or we can just write -2. If you know the slope of a line and the coordinates of a point on the line, you can use the point-slope form to find an equation of the line. And that's what we're going to do in example 2. So still, I'm going to start off by labeling. So I have x1, y1, and then it says slope is -4, so that's m. Point slope is y minus y1 equals m times x minus x1. So now we're just going to go ahead and fill in the information that we have. Y is always going to stay as it is. Y1 in this case is -2. M is -4. X will always stay as it is. And x1 is 6. Now we can go ahead and simplify. My two negatives are going to make a positive. And then we're going to need to distribute the -4. So we're going to end up with y plus 2 equals -4x plus 24. Then I want to get the y by itself, so I'm going to subtract 2 from both sides. And I'm going to end up with y equals -4x plus 22 as my final answer. For the last example we're going to look at together, they're only giving us 2 points. So we need to figure out how we're going to work this with only 2 points given to us. First thing I'm going to do, label my points, x1, y1, x2, y2. And I can use my slope equation, which is m equals y2 minus y1 over x2 minus x1, and my point slope equation, y minus y1 equals m times x minus x1, to figure out the line of this equation. So I'm going to have to use both of those. I'm going to start off with the slope. So I have m equals y2, which is -3, minus y1, which is 7, over x2, which is 3, minus x1, which is -2. Turn my double negatives into a positive. -3 minus 7 is -10, and 3 plus 2 gives me 5. I can reduce that to -2 for the slope. Now I'm going to use my point slope form. So y minus, I'm still going to use the y1 that I originally labeled up here. So y minus 7 equals the slope that I just got, which was -2, times x minus that original x1 value, which was -2. Double negatives turn to a positive. I can distribute, so I have y minus 7 equals -2x minus 4. And then I'm going to add 7 to both sides to get y equals -2x plus 3 as my final answer, which in this case corresponds to letter B.